What are the equations? So if in the question we get an equation of this form, x square plus y square is equal to r square, this is a circle equation. And hence, in this case, we have to draw a circle which is centered at the origin, but the radius of the circle will be r. The equation is very important here. So the coefficient of x square needs to be 1. The coefficient of y square needs to be 1. There needs to be a positive sign in between, and there has to be a constant number on the right hand side. Then, whichever number is on the right side of the equation, that is r squared. If we take the square root of that number, we will get the radius of the circle, which is r. But the key thing is, if you have x square plus y square, then the center of the circle will be the origin, 0 comma 0. Now let us consider a more general equation. If the equation looks like this, ax square plus by square is equal to c square. So in the previous case, the value of a and b was 1. That's why it was a circle. In a case where a and b are not 1, or let's consider a and b are not the same, a and b are different. In that case, the shape of the graph is an oval or ellipse. So consider this. So do remember, when the value of a and b are not the same, then it's an ellipse or basically an oval. But there are two variations to this. Consider an example: 2x square plus 7y square is equal to 6. First of all, the coefficient of x square and y square, they are not the same, which means the graph will not be a circle. It will be an ellipse or oval, but it will be a horizontal ellipse. A horizontal ellipse basically means an oval which is flattened out along the x-axis. And when does this happen? When your coefficient of x square needs to be less than the coefficient of y square. So a should be less than b. On the other hand, consider another equation: 7x square plus 2y square is equal to 6. Here you will see that the value of a is greater than b. So the shape of the graph is definitely oval, but it will look like this. This is a vertical ellipse, basically an oval which is flattened out along the y-axis. So the logic here is, if a is less than b, it's a horizontal ellipse. If a is greater than b, then the ellipse is vertical. Now, the equations of circles and ellipses are not that important for physics questions, but the next type of equations, the trigonometric graph, those are very important for physics questions. So we are going to start with y is equal to sine x. So the shape of the y is equal to sine x graph looks like this. As you can see, on the x-axis, we have angles 0, pi by 2, pi, and so on. So if you observe, the value of sine x is 0 at x is equal to 0, which means if the angle is 0, the value of sine will be 0. The maximum value of a sine function is positive 1, and the minimum value of a sine function is negative 1. And if you observe very carefully, y is equal to sine x is going to repeat itself after every 2 pi radians. So the value of sine is 0 at 0, and it is also 0 at 2 pi. And after 2 pi, the shape of the graph just repeats itself. In other words, in mathematics, we say that the period of sine x is 2 pi, because it is going to repeat itself after every 2 pi radians. But for physics, all we need to remember is just the general shape of the graph. On the other hand, y is equal to cos x. So the shape of y is equal to cos x is exactly the same as y is equal to sin x, but there is a slight difference. So look at this graph. As you can see, the graph is exactly the same, but the only difference is it is going to start with 1. So if x is equal to 0, then the value of cos is 1. Even in this case, the maximum value of a cos function is always positive 1, and the minimum value is negative 1. And like in the case of sin x, the period of cos x is also 2 pi, which means the shape of the graph is going to repeat itself after every 2 pi radians. And now we will consider the third trigonometric graph, which is y is equal to tan x. How does y is equal to tan x look like? So this might seem a little complicated, but the shape looks like this. So the value of tan is 0 if x is equal to 0. Then as you can see, as the value of the angle increases, as we keep increasing the value of x, the value of tan, it keeps increasing. The value of tan 0 is 0, but the value of tan pi by 2 is not defined, or infinity. So if you observe carefully, if we go from 0 to pi by 2, the value of tan goes from 0 to positive infinity. On the other hand, if we go slightly right side of pi by 2, let me repeat, if we go slightly right side of pi by 2, so basically pi by 2 plus something, then the graph will go in the negative infinity territory. So the graph is still increasing, but it is increasing from negative infinity and until it crosses 0, and then the graph repeats itself. So in case of tan x, you can see the graph is going to repeat itself after every pi radian. So in case of sine and cos, the period was 2 pi. In case of tan x, the period will be pi. And now if we analyze the graph, we can say the value of tan theta is positive if theta is acute. By acute, we mean the theta lying between 0 and 90. So observe, if the angle is between 0 and 90, the graph is lying above the x-axis if I consider the angle to be greater than 0 but less than 90. And that's why we say tan will be positive if theta is acute. On the other hand, tan theta will be negative if theta is obtuse. What do we mean by obtuse? The angle needs to be between 90 and 180. So if you look at this graph, if the angle is greater than 90 but less than 180, the graph is below the x-axis, and that's why we say tan theta is negative. And now we can sum up. As the value of theta increases from 0 to pi by 2, tan theta definitely increases, as you can see, but it is positive. On the other hand, if theta increases from pi by 2 to pi, on the other hand, if the value of theta increases from pi by 2 and goes towards pi, then also the value of tan theta increases, but the value of tan will be negative since the graph is below the x-axis. And this completes the equations of different kinds of graphs. And now we are going to consider all of these equations, but with a slight difference. What we'll do, we had considered x and y axis in all those equations, but now we are going to change the axis. So let me explain this one by one. Remember, y is equal to 3x square. It's a quadratic equation. So the graph will be a parabola, an upward facing parabola like this. But please note very carefully the axis. Here we have x axis and y axis. In certain physics questions, what they might do, they might change the axis. So for example, y axis is the same, but look at the horizontal axis. It is not x anymore, it is x squared. So what do you think will be the shape of the graph if the axis is not x, but it is x squared? So it's actually simple only. If you analyze, y is a parameter here and x square, consider x square as a variable. And let us say x square is t, a new parameter. So the equation will become y is equal to 3t. So the equation becomes linear all of a sudden. So y is equal to 3x squared is definitely quadratic as the power of x is 2. But we can transform this equation to become a linear equation. How do we do that? If I take x squared to be some other parameter, let's say t, so you will get y is equal to 3t. Now y is equal to 3t is of the form y is equal to mx plus c. And remember, y is equal to mx plus c was a straight line. And hence, in this case, y is equal to 3x square will be a straight line, as you can see, but this line is having a positive gradient since the coefficient of x square was positive. But since we do not have anything in front of x square, there is no number in front of x square. So basically, we can just say it is y is equal to 3x square plus 0. That is why it is a straight line passing through the origin. So let me repeat, if the horizontal axis is the same as the parameter on the right hand side of the equation, in the equation we had an x square and that is the same as the horizontal axis. In such cases, the equation will be a straight line. But the gradient will be positive or negative depending on what is in front of x squared. So basically the coefficient of x squared. Now let us consider another example. Y square is equal to 4x. Of course, it's a parabola, but it is a rightward facing parabola like we had discussed earlier. Now the shape of the graph is a curve because the axes are x and y. That's why it was a rightward facing parabola. Now if we change the axis, observe the vertical axis here is y square and the horizontal axis is still x. All we need to do is consider y square as some other parameter. Let's call that as t. So our equation will become t is equal to 4x. So all of a sudden, y square is equal to 4x, which is quadratic, becomes a linear equation. So t is equal to 4x. So if the vertical axis is the same as the parameter on the left hand side of the equation, then the graph again is a straight line passing through the origin. And why is it passing through the origin? Because there is nothing being added or subtracted in front of 4x. I hope it is making sense. Let's take one more example. Y is equal to 2x cubed. Now we have discussed already the shape of the graph looks like this, but this shape is only because the axes are x and y. Now if I change the axis, vertical axis is the same y, but the horizontal axis is now x cube. So the same steps are to be employed here. So x cube is the new parameter here. So the new equation will be y is equal to 2 times t. Hence the shape of y is equal to 2x cube will be a straight line if the horizontal axis is x cube. And this is how you transform the graphs when the axes are changed. But please bear in mind, I'm only taking those parameters which are in the equation. For example, if the equation is y is equal to 3x squared, I'm taking x squared as the horizontal axis. Similarly, here we had y squared, so the vertical axis was y squared. Here we have an x cube, that's why horizontal axis was x cube. Now consider a case if I have to draw the shape of y is equal to 2x cube where the horizontal axis is x squared. Let me repeat, x squared. So then in that case, the shape of the graph will be much more complicated, which is beyond the scope.